Match each function to its interval as it appears on the graph below. There will be functions and intervals left over when you are finished, since we have this crazy looking graph here. And what we want to do is think about what expressions define the different parts of this graph. So if we thought, for example, that in the interval between where x is greater than or equal to 3 and x is less than 7, that this is being defined by 1 over x, we would drag this into that just like that. So to help us think through it, I've copy and pasted this thing onto our scratch pad. And let's just go interval by interval. So this starts at x is greater than -4, not greater than or equal to, or we could say it starts at -4 is less than x, not less than or equal to, because the function is not defined at -4. We have an open circle here. But let's see what a good candidate expression is for this part of the function. So to do that, let's just find some nice, well-defined points here. So it looks like we have the point. That point over there is the point -2 comma, looks like 1/2. We have the point here, which is -1 comma 1. And those look like two good ones. So let's see which of these seem to work, at least for those points. Maybe we can rule out some. So 1 over x. So let's see. If x is -2, 1 over x would be -1/2, not +1/2. So this isn't being used to define this first section. So we can rule that out for at least the first section. Now let's see. F of x is equal to -1 over x. Now this looks pretty good. -1 over -2 is +1/2. So it works for that. -1 over -1 is 1. So this right over here seems to work for at least this interval. So it seems to work. We're doing -1 over x. And it seems to work even after that, where if you took we have the point right over here, 1, -1. -1 over 1 is -1. And over here you have 2, -1/2, which is also consistent with this right over here. So I would throw this one. And so this function works from the interval -4 is less than x, which is less than or equal to 2. So that's this interval. That's this interval right over here. So let's actually fill that in. So that is this interval. Actually, you can't see it. It's off the screen right now. That is that interval right over there. Now let's get back to my little scratch pad. Now our function is not defined for x between 2 and 3, but then starting at 3, the function gets defined again. And let's do the same thing. Let's look at some interesting points that might prove valuable. So this point right over here, actually let me do it in magenta. You have this point, which is the point 3, -2. You have this point right over here, which is interesting, 5, 5, 2. So let's test some of these points out and see which of these work. Well, 1 over x definitely doesn't work. 1 over 5 is not 2. -1 over x doesn't work. -1 over 5 is not 2. 1 over 5 squared is not 2. 1/2 times 5 plus 5 to the third power. That's 10 to the third power. That's 1,000 times 1/2. That's 500. This goes to 502, not 2. So we're going to rule this one out too. So let me rule it out for the interval that we now care about. We now care about this interval, or this part of the function. So let's see. If we have 5 here, 5 minus 5 is 0. To the third power is still 0. Times 1/2 is still 0. Plus 2 is 2. So this point is consistent with this function for right over here. Now let's see, does that work for 3, -2? 3 minus 5 is -2. To the third power is -8. Times 1/2 is -4. Plus 2 is -2. So this looks like a pretty good candidate. Let's just try to see if we make sure we can rule this one out too. Well, let's see, 5, 2. Let's see, 5 plus 5 is 10. Squared is 100. Times 1/2 is 50. 52, not 2. So we can rule this one out as well. So it looks pretty clear that we could use this expression to define the interval x is greater than or equal to 3 and less than 7. Not less than or equal to. It's not defined at 7. So we could use this for this interval right over here. So let's go back to the actual exercise. And so we said this one for this interval right over here. And let's make sure that we got it right. So check our answer, and we did.